This video is for the pre-lab for the year molar mass determination by freezing point depression and molar mass determination by boiling point elevation. Okay. Both of these properties are what we call a colligative property of the solution. Okay. The colligative property of the solution is a physical property of the solution that changes when you add a non-volatile solute into the pure solvent. It will change that physical property of the solution. The property of the colligative property depends only on the concentration of the solute particle, not the type, okay, not the identity of it. For example, when we express the concentration of the solution using molarity of the solution, okay, molarity of the solution is the number of mole of solute per kilogram of solvent, okay, per kilogram of solvent. So solute and solvent. Okay, so we talk about concentration. Okay. Then, for example, when we look at the graph between the pressure versus temperature, okay, the black line here represents the phase diagram of pure water, pure liquid solvent. Okay. For water, the freezing point is at 0 degrees Celsius. But once you add the non-volatile solute into the water, it will change the freezing point of the solution. It's going to drop down. Okay? It's going to drop down. That's why we call it freezing point depression. It's going to drop down from 0 to minus something. Okay? So that's it changing. And you can calculate the change by subtract the two value. Okay? These two value. Same here as the boiling point. If you follow the phase diagram of water, we look at the pressure at the boiling point at 1 atmospheric pressure of water is usually about 100 degrees Celsius. But when you add some non-volatile solute into the water, it changes the physical property of that solution. The look at the boiling point of the solution is higher than the boiling point of the pure water alone. So the difference, you can calculate the difference between this boiling point by subtract these two values. Okay. Next, in this experiment, our goal is to calculate the molar mass of your solute. Okay, we're going to use sodium chloride in this case. So in order to calculate that, one thing we know about the freezing point depression, the magnitude of the freezing point depression can be described in this equation. So the changing, so we already know how to do the changing in temperature, right, of freezing point temperature, equal to I is a Van Hoff factor, Kf is a freezing point depression constant of the solvent. The common solvent that we use is water. So Kf in this case, 1.86 degrees Celsius per molar, is the freezing point depression constant of water. Okay, and okay, let's go back to about the Van Hoff factor is what happened when you add sodium chloride in solution. You see that in solution, sodium chloride will break down into sodium ion and chloride ion, and therefore the total dissolved particle present in the solution will be 2. Plus and minus, so I value of sodium chloride will be 2. So, and Kf is 1.86. You know the changing in the T sub F, the freezing point depression, from the experiment. You can calculate the molarity, okay, molarity of your solution. And you know that molarity is the number of mole of solute per kilogram of solvent. And therefore, okay, knowing this, once you get the value of molarity, you know you can calculate number of mole because you know how much solvent you add because you have to measure it. Okay, so you know how much solvent that you use. Okay, at the beginning solvent in this case is water, and then you calculate number of mole of solute. Okay, so again, if you go back to Gen Chem 1, you know that number of mole is equal to mass of the solute divided by molar mass of the solute. Now, number of mole of solute you obtain from this calculation here. Mass of solute come from the experiment. you rearrange the equation and you can calculate molar mass of the solute. Okay. One other thing that you need to do for this experiment, additional information that must be included with the lab worksheet. Number one, you must show all the steps of your calculation. So when you try to calculate, you have to show how do you obtain your molar mass. That's number one. And number two is the additional information that need to be included in your worksheet is percent error from your experiment. Okay. The actual molar mass of sodium chloride is 58.44 grams per mole. Okay. You will calculate percent error from your experiment and show your work on that. You can use additional page, or you can if you have room in your worksheet, you can add that on, but you got to show your work. To remind you, percent error is the actual value subtract from experimental value. Don't forget, this is absolute difference. Divide by the actual value, which is 58.44. Multiply the whole thing by 100. You will get percent error from the experiment. Okay. The next thing is you will follow the same thing when you work on the experiment called the molar mass determination by boiling point elevation. So the equation is very similar. The difference is instead of using the freezing point, we use the change in the boiling point temperature. Instead of using the Kf, okay, we use the Kb, which is the boiling point elevation for water is 0.51 degrees Celsius per mole. Everything is pretty much the same. Okay, same technique. You solve for the molar mass of your sodium chloride. Then again, for this experiment, this is the different experiment. So make sure you do the same thing. You got to show all the steps of your calculation, and you have to do the percent. Okay, the worksheet did not ask you, but I asked you to do that. Got to be included in there. Calculate percent error from your experiment. You must show your work. Okay. All right. If you have any questions, please let me know. Okay. If not, good luck. Okay. Bye bye.